So it's been a while since I did a update on my Prusa Mendel 3D printer project, and it's not for lack of interest. I've actually been working on it hundreds of hours to get the printer to be reliable. It took me about 4 weeks to get the printer working. It's taken me an additional 5 months to get it working well and reliably. And I thought it'd be a good idea to do an update and catalog some of the changes I've made. The original design on the y-axis and the heated bed, I had some trouble with it. I had problems with the bed not being flat, which would cause issues with parts sticking on the edges. The parts, especially with ABS, they tend to warp on the edges, and the edges tend not to stick very well anyway, which is part of the reason why you have a heated bed rather than just a flat surface. And I was having trouble with mine not being perfectly flat or not being very flat, and this was exacerbating the issues with parts sticking on the edges, especially with ABS plastic. PLA doesn't warp as much as ABS, and so it wasn't as big of an issue there, but I thought it would be a good idea to re-engineer the bed, so I kind of started over from scratch. The old bed was made out of masonite on the very bottom layer of the y-axis carriage. I had problems with this flexing. The springs would actually pull up the corners and cause it to flex, so I had to get rid of this. This didn't work. I also had the bed itself was made out of plywood. So this was the old bed. It's made out of plywood, and it was covered in a gold heat shield material for race cars. And this warped, basically. It didn't stay flat. And I don't know if that's just because it's plywood. Probably. Plywood's, not known for its, necessarily staying flat. So this wasn't a good material. And the top layer, I had a very thin piece of aluminum covered in Mylar tape. And this also warped, and not necessarily warped, but it was crowned in the center. And that was the biggest issue. So the crowning in the center, the higher spot in the center, and then the lower spots on the edges, was causing the parts to pull up on the edges. So I thought, well, let's start over. And what I decided to use was a material called cast tooling plate for the bed. It's a 6061 T6 aluminum, which is kind of your standard aircraft grade aluminum, but it's cast, and it's engineered to be, flat plus or minus 1/1000 of an inch across its surface, so it's very flat. It's used typically for tooling and jig fixtures in machine shops, and so it's a nice flat material. And so that's what I'm using now, and it is a 1/4 of an inch thick, I believe. I also had a piece of scrap aluminum plate in my scrap pile, and that's what I used for the bottom carriage. The bottom carriage is made out of 6061 T6. I think that's an 1/8 of an inch thick or something like that. And then I threaded the holes for that, for the bolts going through there. And then there's the springs, of course, and the washers. And then I machined the cast tooling plate. I originally engineered it so that the printed circuit board would actually sit flat. You can see the channels that I milled out for the thermistor and for the power connections, so that I set it up so that the printed circuit board would actually lay flat against the cast aluminum tooling plate. Thinking there was that would make it nice and flat because it would be resting against the tooling plate. I also threaded the holes for the into the tooling plate for the bolts that are holding the printed circuit board down. And what I found was when I actually had the printed circuit board resting against the tooling plate, of course the tooling plate's made out of aluminum, so it acted like a big heat sink and drew heat away from the printed circuit board, and actually made it more difficult and slower to heat up the printed circuit board. So I thought, well, okay, back to the drawing board there. So I put aluminum standoffs, one in each corner. They are, I believe, a 1/4 inch aluminum standoffs, and then washers on top, and then of course the bolts holding it down. They're basically little Allen screw, button head Allen screw bolts that are holding it in place. So the upshot is the bed is now much flatter, and it's not prone to warping, and it doesn't have a crown in the center. It's not perfectly flat, but it's flat enough for our purposes and works reasonably well now. Also, the bed is currently covered in blue 3M blue painter's tape. This stuff that you get in any hardware store. Reason for that is I'm currently printing with PLA plastic, polylactic acid plastic, which is a plastic that's derived from cornstarch. It likes the blue painter's tape. It sticks well to the blue painter's tape and comes off of the blue painter's tape when you're done. ABS plastic, which is the other type of rep plastic, likes this Mylar tape, the Captain tape. This is obviously more expensive and harder to come by than the blue painter's tape. The other thing is, it's much fiddlier to put the Mylar tape down. It's kind of like tinting windows. You get a lot of bubbles in it. It's very fidgety to line everything up, so you don't have a lot of big seams or anything. I can lay the blue painter's tape down in about 1/10 of the time it takes to lay the Mylar tape down. So that's kind of nice. Nice material to work with. The other thing I did was I basically started over with a new extruder and new hot end, and I'll do another video about the extruder and hot end because that's a whole nother tale, and I don't want this video to get too long. So thanks for watching this video, and I'll do another update today.